Now we are going to talk about observer design pattern. This design pattern is very common, very widely used, and any kind of software development, whether it is small solution or whether it's a complete framework, big framework. So you will be using this design pattern, observer design pattern. So as the name says, there will be number of observers which will be observing certain event, certain state of certain thing. Okay, so for example, I'll give. Suppose there is a low power dependency in your application. So whenever device goes into low power mode, you want to do certain action. So like you as an application want to do certain action, there would be number of applications which want to do action. Their action may vary based on and their use case. Their action will vary, but all of them want to listen the power mode. So here power manager becomes the subject whom so many clients are observing, right? So whenever certain threshold reaches or anything happens, then this power manager will basically intimate all these listeners. So here what happens is all these clients basically registers to the subject that I want to listen certain kind of event, and same way all the other client does. And whenever that particular incident or event happens, the subject triggers to all the listed listeners, and basically it calls all the callbacks of those listeners with certain information. Okay, certain message. So that is all about the design pattern, and now we will be seeing this code. So here I'm creating a class I observer. So class subject is the one whom which will generate event for all the observers. Okay, and these are the clients here, display and audio. Okay, and this is basically an example I have created. The theme of this example is like we all use Bluetooth headset, right? So some of the Bluetooth headset has display as well, very small minor display, or maybe a LED indicator, as well as audio is obviously part of Bluetooth headset. So whenever power level goes down to certain threshold level, what we are going to do is we will be switch off the display first. Okay, if it goes below 20% of the power level, but audio will still continue. It will just alarm the user that battery level is down low, and it will still continue with playing audio. And when audio is completely drained off, till that time audio will continue, but display will be intimating to the user for every percentage drop below certain threshold level. Let's say this threshold level is 30%, which means below 30% of battery level, all the listeners will come into action, which means they will start handling based on certain condition. So like a display here is going to switch off. It's going to basically display a certain message on the screen if it is below 30% of threshold. But at certain level, let's say at 10%, when battery reaches to 10%, display will be completely off. Okay, so that is the theme here. So based on that theme, I have created this example. So we have one subject class here, home, which is basically power, you can say battery monitor. And whenever battery level goes below certain level, it will start basically notifying to all the listeners who have implemented iObserver class. So here display and audio are the two listeners which want to listen the subject, and so they have implemented iObserver class. So how they have done, let's see here. So iObserver says that I want to listen subject or uh, event or state from the subject whenever there is an event from the subject, and subject says that I'll let all the observers know when certain event is has occurred. Okay, so that's how this is just comment. Okay, this audio and display are the listeners, and this is main is for test. So basically in observer iObserver we have created one function update, and this is going to update with certain message, a string message, and this is a pure virtual function we have created. So this is an abstract class which is not necessary, but mostly it will be abstract class in most of the cases. So here subject basically what it does is it contains a container. It contains a list as a container for all the observers. So basically whenever any observer registers to subject for listening any of such update event, it will basically register here. List will maintain those observers, object of those observers, and this notify all, which is a private function, will be iterating through the list here, and it will let all the listeners know that certain event has occurred. So yeah, so here we are using shared pointers. So we are iterating through the list of observers, and we will update with low power message here. We will notify to all. Okay. So this notify all will just notify, but what is the condition we are going to implement later in this subject class? So here the register listener is the function where all the listeners will be registering their um, callbacks. So unregistered listener, we are using all here shared pointer, which is very handy here. And when any of the listener don't want to listen any further for whatever reason, they will unregister from here by calling remove API. Okay, now we are going to implement here battery level as a function. And this function will basically call to notify all when we have defined here battery threshold as 40. I don't know, 40 will be good, but just for sake of example here. So battery level is we are just printing out here. So if battery level, that is val, is less than or equal to battery threshold, we are going to call notify all, right? Let's make it 30. Okay, 30 is a battery percentage threshold. So whenever it is below or equal to 30%, we are going to notify all the listeners here. So what we will do is we'll implement display. Here display is a class here, or let's say maybe it in real example it will be some kind of service for display stuff here, and just to hold for logging purpose, hold the name of this class. We are assigning this function name, constructor function name, to class, so that we'll have this class name in our logs. So here we are implementing update. Okay, we are going to override. Okay, there is override is showing some here. Yeah, so we have to make const, and we are making this is pure virtual function, and this pass by message is passed by reference here. Okay, so that's the reason we kept const, so that it should not be changed. Okay, anyways, so now we are going to log this message on the screen. So whenever there is update to display for battery level, it will display on the screen. Same thing what we are going to do for audio. Okay, fine. So we have two classes which are derived from the iObserver. Okay, and then we are going to make a unique pointer here. Unique pointer subject The reason is the scope of this particular subject is within this main function. We are not going to share um, this pointer with anyone. That's the reason we have created unique pointer. Now we are going to make a shared pointer. The reason is we are going to share this over a function call. We are going to register a callback here. Okay. So I will try to cover this smart pointer also in some of the some other day. Okay, just for okay, fine. Anyways, so these two pointers we have created share pointer, and then display and audio. Okay, and then we are registering display. We have registering. Okay, now subject we have registered display, and then we are going to trigger battery level here from for the subject from here, and let's see. So we are giving starting from 80%, 80, 70, 65, 50, 40, 30, 20, and 10. And for each percentage level, there will be a message. And if there is this thread goes below the threshold, equal to or below the threshold, that is equal to or less than 30%, we are going to let display and audio know that battery level is done. Now we are going to unregister one component display here. So when it reaches to 10%, display will not be notified, only audio will be notified. Yeah, you can see here the log. So in this log we are getting low power below 30 for display and audio, but at 10% we are not going to get for display, we are going to get only for audio. The reason is this display will be off when it reaches to 20% of threshold.